Students, and welcome to today's lesson. I'm Mrs. Baidani. Today, we will explore the question, how can we use the Earth-Sun system to tell time at different locations on Earth? Are you ready? Grab your pencil and your science journal, and let's get started. Hey, I was thinking about our sundial models and how we might use them to determine times of day at different locations all over the world. Remember the shadow in the United States was different than the shadow in Argentina? How interesting! And the shadow in the United States was different from the shadow in Cairo, Egypt. We drew models to explain the differences in the shadows at different locations at the same moment in time. This model shows the equatorial view, so we can see the shadow in the United States location and the shadow in the Argentina location on the same model. This model shows the view from above the North Pole of Earth, so we can see the shadows in the United States location and in Egypt, since those locations are both in the Northern Hemisphere. At a given moment in time, the time of day is different in different locations on Earth. How does your model help explain these time differences? Well, the shadows are at different positions in the different locations, right? And we learned that shadows change position throughout the day. So these shadows tell us that different times of day are occurring at the same moment around the world. That information is so fascinating. We have been using the word time, but are we talking about time on the clock or a moment in time? Well, at a given moment in time, when the Earth and the Sun are in certain positions, clocks in different locations on Earth show different times. When the time is 4:35 p.m. in New York City, the time is 9:35 p.m. in London, England. Let's look at different time zones in the United States. Which state do you live in? Point to your state on the map. What time zone is your state in? I live in Texas, so I'm in the Central Time Zone. One of the reasons time zones were developed was to account for the differences in shadows, just like the shadows we observed in our models. As the Earth rotates, the shadows in different parts of the United States will differ. That means, even within the same country, different parts of the country experience different times of day at the same moment in time. How does this time zone map relate to our SpaceView sundials? Well, our sundial models show us why it's a different time of day in different places. And this map has clocks showing different times in different parts of the country. Remember that east is in this direction. In our model, we saw that locations that are further east experience sunrise earlier. On this time zone map, the Eastern time zone is 1 hour ahead of the Central time zone, 2 hours ahead of the Mountain time zone, and 3 hours ahead of the Pacific time zone. So the Eastern time zone experiences sunrise first, followed by Central, Mountain, and Pacific. This time zone map supports our observation that locations that are further east experience sunrise earlier. Nice work! Why do you think people develop time zones? Well, the sun rises at different times in different locations, so time zones might help keep sunrise at about the same time on the clock for everyone. And when you travel to a new place, the time zone will help you know the time in your new location, right? Before the development of time zones, people used the sun to tell time, so local time varied from one city to the next. Time zones in the United States were developed as people began traveling more frequently on the railroads across the country. As more people began traveling by train, they needed a schedule for train arrivals and departures. Because there are different time zones around the world, each hour of the day is being experienced by someone on Earth. In this lesson, we will explore how the apparent movement of the sun across the sky determines time around the world. Let's revisit our sundial models. Look closely at the shadows on the models to observe what is happening in different places around Earth. What do you notice about the sundial shadows in the models? Do you notice that the shadows in different parts of the world are pointing in different directions? If yes, nice job. Hey, do you also notice that the shadows for different locations on either side of the equator are different? How interesting. The equator is the line that cuts the globe into north and south halves. All locations north of Earth's equator are in the northern hemisphere, and all locations south of the Earth's equator are in the southern hemisphere. Have you heard the word hemisphere before? A hemisphere is half of a sphere. The prefix hemi means half, and the sphere is a round, three-dimensional figure such as a globe or a ball. So, on our sundial models, we place sundials in locations in both the northern and southern hemispheres. What observations were the same in every location? In other words, how is the use of sundials in the northern and southern hemispheres similar? Well, remember, the Earth spins in a counterclockwise direction. So maybe you observed that the shadows move from west to east throughout the day in both hemispheres. That is a great observation. What other observations were the same in every location? Think about the shadow positions at different times throughout the day. Were the shadow positions the same everywhere, or did they differ depending on location? What about the length of the shadows? What would the length of the shadows look like at different times of the day? As you make your observations, imagine the model rotating. How does the Earth's rotation affect shadows on a sundial? But there are differences too, right? How is the use of sundials in the northern and southern hemispheres different? Did you notice any differences in the shadows? How did observations differ between locations? Your task at the end of today's lesson will be to add both similarities and differences to the chart. Wow, we learned so much today about the Earth-Sun system's influence on shadows and time. Our location on Earth and even our location in the United States can help us determine the position of the sun in the sky at a given moment in time. What time will the sunrise be tomorrow? Will other people in the United States see the sunrise before you? The answers to these questions depend on where you are located, right? In the upcoming lessons, we will begin to explore our views of the moon in the sky. I can't wait! Let's review your task for today. Complete the comparison chart.